In the final video in this section, we're going to go through and try to go backwards from function composition, and we're going to find two functions such that f composed of g is equal to h. And the easiest way to do this is to look at the inner function and decide which one's going to be the composed function or the function that's going to be inside, and that's going to be g. So we're going to say g is going to be the inside function, or I'd like to call it the smaller of the two functions. And f is going to be the outside function, okay, or the bigger of the two, okay? So, and I know that might not make sense too much, but that might be the easiest way to think about these, all right, if you're thinking at it from a non-mathematical standpoint. Now, I look at this first h of x, and that's 3x minus 4 to the fifth power. And the function that's inside is the 3x minus 4. All right, so that's pretty easy to see. And so what we're going to do is we're going to define g to be 3x minus 4. And then the outside function, the bigger function, is x to the fifth power. So f at x would be x to the fifth. Now, let's check this by finding f at g at x, all right? And that would mean that I would stick 3x minus 4 back in for x, and that would be 3x minus 4 to the fifth power. And that's precisely what we needed, okay? So these would be the two functions that we need to be able to compose h, all right? So that's all we're looking for. We're just looking for two functions that when composed, they give us this resultant function h at x. Another example, h at x is 4x minus 1. And so once again, we see that the smaller or inner function is this 4x minus 1, right? So I'm going to call g at x, I'm going to call that 4x minus 1. And then I'm going to call not h, but f at x. Let me rewrite these so they make a little more sense, right? So f at x is going to be the square root function, all right? Now, of course, if we don't trust that, let's go ahead and stick 4x minus 1 back in for x. And so that would be the square root of 4x minus 1, or f at g, which is exactly what h at x is when we started with that. Okay, so that's all we have to do with that. Not too bad, right? And our last example, this one's a little bit sneakier. And so we have 7 minus x cubed over negative x cubed plus 2. All right, so again, this one's a little bit sneakier. And the way we could define this is I could let g, because there's no parentheses with this one, which is why it's a little sneakier, but let's let g be equal to x cubed, because we notice that there's a couple x cubes in this. And so that would mean that f would be equal to 7 minus x over negative x plus 2. Another way to define this, if you elected to, is you could make g be equal to negative x cubed, and that would mean that f could be equal to 7 plus x divided by x plus 2. Right? So there's a couple ways to be able to get to our answers. And of course, if you don't trust me, you could just go ahead and substitute back in g into f, or f at g at x. All right, and you can do the same thing here. And you can clearly see that these two compositions will give you the resultant h of x. All right, so this is probably going to be, I'm not going to say the better answer, but probably the more simplistic, because we always like to try to keep things positive when possible. All right, but I don't know if there's any difference between the two. All right, so that's all for operations on functions, domains, and then also composition of functions. So in the next section, we're going to take composition just one step further, and we're going to start taking a look at inverse functions, okay? And inverse functions are going to be a huge part of calculus for those of you all that have to take Calculus 1.